Ah, there it is. Hi guys. Let's look at conservation of mass and balancing equations. Took me a second there with my phone because, as we all have figured out, I'm super brilliant. So, you know the law of conservation of mass. You've known it since you were a kid. They drilled it into your head. Mass cannot be created or destroyed. Matter cannot be created or destroyed. We can't make something from nothing, and we can't make it disappear completely either. It just changes forms. And we account for that in our chemical equations, which is what we're going to look at today. So here it is for the zillionth time in your life so far. The law of conservation of mass states that mass in an isolated system is neither created nor destroyed by chemical reactions or physical transformations. So, the mass of the reactants has to equal the mass of the products. And because of that, we have to balance chemical equations to make sure that what we start with, we end with. It just rearranges. So how we do this is we write a skeletal equation, then we count the atoms on the reactant side, count the atoms on the product side, and change the coefficients to make sure that the number of atoms equal on both sides. You can only change coefficients. You can never change a subscript, because if I have this, let me see if I can figure this out. Here's my pen. If I have this, right, I've got some hydrogen plus some oxygen, and I'm going to make some water. Well, it looks like, well, that's a bad zero. There it is. It looks like it would just be so simple to put another 2 down here as a subscript, but I cannot do that, because if I do that, I haven't made water anymore. I've made hydrogen peroxide, and that's not the same thing. So I can only change coefficients, the large numbers in front, these guys. Okay? Moving on. Let's look at how to practice this. So what I do is I say, okay, I've got in this equation, I've got some sodium, Na, some fluorine, F, and some bromine, Br. I have that on each side, which is a good thing, because that means I haven't created anything from nothing, and I haven't tried to make anything magically disappear. So I write them all down the center under the arrow, and then I just start counting. So on the reactant side on the left, I have 1 sodium, 1 fluorine, and 2 bromines. I know I have 2 because there's that subscript there. On the product side on the right, I have 1 sodium, 2 fluorines, see that? And 1 bromine. So now I'm just going to go down and look and see if everything looks okay. So sodium, I've got 1 on each side. That looks cool. But on fluorine, I've got 1 on the reactant side and 2 on the product side. So I'm going to put a 2 up here as my coefficient. And I'm going to go ahead and I'm going to say, okay, well, now I've got 2 fluorines, but it also changed my sodiums. So I'm going to come back up here and say, okay, well, let's look at this. I've got 2 sodiums here now. So now I have to come to the product side. I'm going to put a 2 in front of this sodium. And here we go. I've got 2. My fluorines look good. And now, I have 2 bromines as well now that I changed that. So my coefficients become 2, 1, 2, 1. And like you've learned so far in chemistry, if the coefficient is 1, I don't necessarily have to write it. But that doesn't mean 0. If you feel better writing it, please write it, but you're not required to. Let's look at some more. All right. I've got silver nitrate plus copper reacts to form copper nitrate plus silver. Nice little single replacement reaction there where the copper kicks the silver out, and it turns into a copper solution with some silver left over. So what I've gotten here is I've got some silver, and I've got some nitrogen, and I've got some oxygen, and I have too big of the fingers, so I'm going to come all the way over here, and I've got some copper. So on the reactant side, I have 1 silver, 1 nitrogen, 3 oxygens, and 1 copper. On the product side, I have 1 silver, 2 nitrogens, because this guy distributes, 6 oxygens, and 1 copper. That 2 behind CuNO3 only counts for what is in the parentheses. It's counting for that nitrate, not for the entire thing. It would have to be in front. So our silvers look good. Nitrogens don't look so great. So let's go ahead and put a 2 on the reactant side. And so that changes our silver to 2. It changes our nitrogen to 2. It changes our oxygen to 6. But now I got to come back over here because, see, my silvers aren't good. Everything else looks good. Nitrogen looks good. Oxygen looks good. Copper looks good. But silver needs to be 2. So I put a 2 there. And again, I've got 2, 1, 1, 2. And those are my coefficients to balance this equation. Let's look at another one. Let's see if I can erase that mess. Ooh, I can. Check it. All right. Let's see if I can go back below. Here we go. That was awesome. I'm getting so tech savvy. Thank you guys for putting up with me. Here we have sodium phosphate and calcium chloride reacting to form sodium chloride and calcium phosphate. So let's go ahead and count up what we've got here. We've got some sodium. Let's see if I can write small enough this time. Phosphorus, oxygen. I can't write small enough. Calcium and chlorine. All right, and so on the reactant side, I've got 3, 1, 4, 1, 2. And on the product side, I've got 1, 1, 3, 2, see that? 8. All right, what can we do here? Well, first things first, I can look at, let's look at sodium first, since it's the first thing there. Let's go ahead and put a 3 here, and that changes the product side to 3, right? But it also changes this side to 3, and I've got a 2 and a 3. And when I have a 2 and a 3, that makes life a little crazy. So I think to myself, okay, I'm never going to make these match. I can't just change it to like a 4. I can't just change it to, I got to make it work. So what is the least common multiple between 2 and 3? Well, that's 6. So what do I multiply 2 times to get 6? Well, I multiply it by 3, okay? So now I've got 3 calciums. I've got 6 chlorines. I'm going to come back over here, And I'm going to change this all the way up to 6. So let's do this. Okay, so now I've got 6 sodiums, 6 chlorines. So over here, I'm going to put a 2. That gives me 6 sodiums. That gives me 2 phosphoruses. That gives me 8 oxygens, right? So I've got 6 sodiums. That's good, right? 6 and 6, we're good. I've got 2 and 2 phosphoruses. I'm good. I've got 8 and 8 oxygens. I'm good. I've got 3 and 3 calciums. I'm good. And I've got 6 and 6 chlorines. So my coefficients here are 2, 3, 6, 1. All right, last one. Oh, the last one is the answers. Giddy up. Notice that you don't always have to put that coefficient when it's 1. It is perfectly acceptable to leave it off because in chemistry we know if the element symbol is present, then the element is present. It exists. It is there. We balance equations because we know that if I start with something, I have to end with that same thing no matter what. It just rearranges, it just changes forms. You guys are going to do a little Schoology practice. I hope you have an excellent rest of your day, and I will see you tomorrow.